Welcome to this week's midweek space news roundup. I do this every week at the same time, middle of the week, and just round up some space startup news and news that's relevant or affects space startups in some way. We're on X now at Space Startup Hub. Space startup news handle's already taken and it's more than 15 characters. So let's get into the first news item, which is this post from the President Trump. He says, Sean Duffy has done an incredible job as interim administrator of the National Aeronautics and Space Administration, or NASA. This evening, I am pleased to nominate Jared Isaacman, an accomplished business leader, philanthropist, pilot, and astronaut, as administrator of NASA. Jared's passion for space, astronaut experience, and dedication to pushing the boundaries of exploration, unlocking the mysteries of the universe, and advancing the new space economy make him ideally suited to lead NASA into a bold new era. Congratulations to Jared, his wife Monica, and their children Miller and Liv. Thank you for your attention to this matter. President DJT. Okay, so it looks like the nomination of Jared Isaacman is back on track, and hopefully he gets the votes in the Senate, and we have a new NASA administrator. There's been news recently in Politico and Ars Technica, Project Athena, which apparently is a document that was circulating around, written by Jared Isaacman on his plans for NASA. There's a 62-page document that's been leaked, and originally it's over 100 pages. So I want to do a video later this week on that topic because there's a lot to dive into, but that's a topic for another video. So let's move on to the next news item, if I can bring that up. And this is Intuitive Machines, and the title is Intuitive Machines secures $8.2 million Air Force Research Lab contract extension to advance in-space nuclear power technology. So I've just highlighted some areas. It's $8.2 million contract extension from the US Air Force, and it's for next generation nuclear power systems for spacecraft and lunar infrastructure. And it will enable lengthier missions on the moon and in deep space. At first, it may appear like it's a nuclear reactor, but it isn't. You can read next here, it says Stirling-based power conversion system which transforms heat from a radioisotope source into electricity. So what this means, it's basically an RTG, or radioisotope thermoelectric generator, which is basically just uses the natural radioactive decay of a radioactive material, and from that you get heat, and you can also convert it into a small amount of electricity. Typically it's 5 to 7% of the power because you can convert into electricity, but if you use a Stirling engine you can bump that up to like 18%. So NASA is very keen on having a Stirling, what's called an SRG, or Stirling radioisotope generator for Mars. Because of the Martian dust storms, you can't rely on solar power. It's much weaker at the distance of Mars. So SRGs are Stirling-based radioisotope thermoelectric generators is what NASA wants. Intuitive Machines has been working on that technology with the Air Force, and they're preparing the system for flight, making a critical step towards demonstrating space-based nuclear power in orbit. And this is to prevent systems from operating without supplemental power systems like radioisotope thermoelectric generators or battery banks. Demand is growing for reliable, scalable energy systems like Stirling engines. Flight experiment designed to demonstrate Stirling power conversion technology in space and raise the nuclear power technology system's readiness level from prototype to spaceflown. So basically, this system will fly to the ISS, it will be demonstrated on board, and therefore the technology readiness level will be higher, which means it can be used for in-space operations or on the surface of the moon. And it supports critical mission needs by delivering compact, continuous power in space. That's the thing with RTGs and the Stirling-based versions, is that you get continuous power. It doesn't matter whether the sun's up or not. They always generate power because the material, there's always radioactive decay, so that always generates power, which is what you want, because it's whether it's a Martian dust storm or the sun sets, you still need power to run a base or to keep a lunar rover warm or a payload warm. RTGs and the Stirling-based RTGs are the way to go. Intuitive Machines has been studying high-powered nuclear fission-based systems, so now it's talking about nuclear reactors. We believe the progress under the Air Force Research Lab program strengthens our position for future nuclear power programs, including NASA's Fission Surface Power Initiative. So we know from Sean Duffy, NASA will be working on providing a nuclear reactor of at least 100 kilowatts to the surface of the moon. So contracts or grants will be going out to various commercial companies that are working on nuclear reactors. So it looks like potentially Intuitive Machines could bid on the proposal. So that's the first story on Intuitive Machines. There's another story as well. Just bring it up on screen now. Intuitive Machines to acquire Lanteris Space Systems, creating the next generation commercial, civil, and national security space prime. So this expands Intuitive Machines' data services business from lunar and Earth-based operations into low Earth orbit, medium Earth orbit, geostationary orbit, Moon, Mars, and deep space missions. They have a definitive agreement to acquire Lanteris Space Systems, or Lanteris, formerly Maxar Space Systems. So many people will probably recognize Maxar Space Systems. They are providing the power and propulsion unit for Gateway Station. There's more to say about that because definitely Jared Isaacman has some new plans for the Gateway, but I'll probably talk about that more in my next video. Anyway, so it goes on to say, positions Intuitive Machines as the next generation space prime directly in the flow of multi-billion-dollar space programs. This marks the moment Intuitive Machines transitions from a lunar company to a multi-domain space prime. Vertically integrated next-generation space prime that can design, manufacture, deliver, and operate missions from Earth orbit to the Moon, Mars, and beyond. Intuitive Machines' vision is to expand its space infrastructure services from low Earth orbit to geostationary orbit, beyond the Moon and to Mars, says Cam Gaffaranian. If you're not familiar with Cam Gaffaranian, he's the chair of Intuitive Machines. He's also the founder, one of the founders of Axiom Space. He works with a lot of space companies, of which Intuitive Machines is only one. In terms of the highlights for 2025, we've already mentioned the Air Force Research Laboratory contract for advanced in-space nuclear power technology, and this could be worth a lot going forward because NASA is obviously very interested in nuclear power systems for the surface of the moon, not just nuclear reactors, but radioisotope thermoelectric generators, and that will carry on for Mars for sure. And also they're working on a lunar terrain vehicle, and more about that later in the video. And the Commercial Lunar Payload Services, or CLPS mission, of which there's an IM-3 and there's an IM-4. That's worth many hundreds of millions. They also have lunar data relay satellites for NASA, so that could be worth billions of dollars as well. Potentially, Intuitive Machines is going to be one of the very larger space primes going forward, so we'll see how that goes. Okay, on to the next story. Strategic partnership hopes to advance lunar mobility as a service. So we bring this one up. So Techmasters, Orbit Beyond, and Canadan CIS Aerospace joining forces for CLPS mission. CLPS is Commercial Lunar Payload Services. So the article says mobility as a service for upcoming lunar surface missions. So the mission CT4 has been formed between these three companies. These are quite small companies. I don't really know much about them. Techmasters, Orbit Beyond, and Canadan CIS Aerospace. The mission is to provide standardized, cost-effective, and mission-ready surface mobility solutions for NASA, international, and commercial customers. So Orbit Beyond will lead the lander development. Techmasters will serve as prime integration and mission operations partner, and Canadan CIS Aerospace will lead lunar surface mobility activities, including supply of lunar rover platforms, integration support, and surface operations. The Mobility as a Service framework allows payloads from diverse customers to be deployed, operated, and managed on a single rover platform, and it will provide traverse planning, teleoperations, payload commissioning, and anomaly resolution. Through this partnership, we're redefining access to the lunar surface. We can offer NASA and commercial customers a reliable plug-and-play mobility solution for the moon. Mobility as a Service will make surface science and technology demonstrations more accessible, affordable, and repeatable. Our rover platforms will provide dependable mobility and payload operations support to maximize scientific and commercial return. It looks like we've got 3 smaller companies that are combining to offer a solution for NASA, providing commercial payload services, not just for NASA, but for other international space agencies and for commercial operators. Basically, individually, they couldn't do this, but by combining their efforts, they can provide a lunar rover service. Okay, on to the next story, and this is on Orbital Data and Energy Collaboration Accelerates Space-Based Assembly. If you're a regular on this channel, you already know about both of these companies. Rendezvous Robotics and Starcloud have initiated a formal partnership to integrate autonomous modular assembly systems with orbital power and cooling infrastructure for gigawatt-scale data center capabilities in space. Now, there's been a lot of talk recently about these very large data centers being operated in space. Jeff Bezos started this off with his talk about gigawatt data centers in space, and then Elon Musk joined in, and then we've had the Microsoft CEO, and we've had Eric Schmidt from Relativity Space. There's a lot of CEOs from very large tech companies and space companies saying this is the way forward. There's a limit to how much space and energy is available on Earth without really pushing up the price of electricity and water prices. So you really have to scale. You really have to move into space. And I think a lot of companies are now realizing that, and that seems to be the direction. So this is a joint exploration of advanced architectures, development of scalable high-performance computing and energy systems intended for deployment in orbit. As global demand for data and energy accelerates, we're approaching the limits of what can be built on Earth. We can deliver data center scale capability by assembling it in space. Together, we're laying the groundwork for a new class of orbital infrastructure, and they intend to demonstrate orbital assembly's capacity to overcome contemporary mass and cooling challenges. So I recently did a video on gigawatt data centers, and while they do have a lot of advantages, there are some big drawbacks. One is cooling. You need to put a lot of radiators in space, cool the chips down. They get very hot, and it's very difficult to get rid of heat in space. You just have to use radiators. There's no other way. So that's one of the challenges. Obviously, you've got orbital debris and micrometeoroids, so that's a challenge. Also, radiation is a big problem. It can flip bits and corrupt data. That's a big challenge. Microsoft have recently, in fact today, just announced they have some TPUs or trillion power units, whatever, that are radiation hardened. They tested them on the ground, and they can withstand 15 times the margin of what's expected in space. So they're going to demo those TPUs in orbit and scale out to giant data centers, compute AI into space, where you have access to all the energy from the sun, which is enormous amount of sun, and it's very cold, which can help with the cooling. That was very interesting, that story. Okay, on to our next story, and this is on LTVs, or lunar terrain vehicles, or moon rovers. National Geographic has just posted an article with all 3 of the candidate LTVs. So let's bring up that article now and have a read of it. I'll post the link in the description. It's a very, very long article, but cool photos and cool videos. I've highlighted a few areas. So first of all, if you're not familiar, here are the 3 LTVs. You have the Eagle vehicle from Lunar Outpost. You have the Flex rover from Astrolab, and you have Moonracer from Intuitive Machines, which we've already mentioned in this video already. So they're doing quite a few things. One of them is an LTV. So let's see what the article. There's a lot in this article, but I just highlighted a few things. So this will be to establish a permanent presence up there to lay the foundations for a base on the moon's south pole, a fortress among the stars. So this is NASA's Artemis plan for a sustainable return to the moon, the Artemis Base Camp. But you're going to need rovers to move around for surveying, for exploration, and so on. So NASA is looking for at least one of these. There's 3 of them. It's definitely going to be one of them being sent to the moon, but potentially commercially all 3 could be available, I guess. Being driven remotely from Earth or scooting themselves around the lunar surface autonomously. So the requirement from NASA is they can be teleoperated, potentially that's from Earth or maybe from the Gateway Station, and they can also be operated autonomously, which means even when you don't have astronauts on the moon, the rovers can be doing science, they can be doing exploration, be doing surveying, and just operated from the Earth, just like NASA operates the Mars rovers from Earth. The lunar south pole is where the regolith is thought to be suffused with water ice, which can hydrate astronauts, grow crops, and make rocket fuel. So here we have the Lunar Roving Vehicle, as it's called, and this was exploring the moon in 1971, and this Apollo mission number 15. Each LTV is required to be capable of driving for 800 miles each year and 12 miles each day on a single battery charge. All three rovers are designed to use a robotic arm to assist with construction. Each transport must persist for several years, requiring essentially no maintenance. So the first one they drive around is Lunar Outpost. You can see in the video here they're driving it around. This is the Eagle rover. So yeah, there's some nice video of them going over bumps and slopes and so on. There's a cool photo of it. You can see they get in at the front here. Plenty of space, plenty of other photos as well. You drive Eagle at a top speed of 16 miles an hour. Weaker gravity makes braking take far longer on Earth, and LTVs also feel nearly impossible to tip over as I meander through the scrub. The problem is that may be the case on Earth, that's not the case on the moon. With much lower gravity, there's less traction, so it's much easier to tip over. The only real solution to that is to drive slower. In my video on lunar roads, I talk more about the traction problem, but you really can't drive very fast on the moon unless you have prepared surfaces, in other words, you have roads. Otherwise, you're going to lose traction, you're going to tip over, and you don't want to do that. 30-degree lunar-like slopes in thermal vacuum, fine, but I don't think on the moon you should ever try a 30-degree slope. That seems to be more than you can manage. I think it's likely 10 to 20 degrees. Because of the lack of traction. I could be wrong, but I don't think you would want to do a 30-degree slope. Towable trailer can be attached to Eagle. Expansive storage space behind its cockpit. Could be the backbone of the Artemis mobility program. Then on to Astrolab. This is the Flex rover, or the Flexible Logistics and Exploration rover. So you've got storage space at the front, hopping at the back, and there's a joystick to move it around. So that's pretty cool. A series of cubic compartments on the front, one that can house tools or robotic arm components. Two astronauts, instead of sitting, hop up at the cockpit and stand or lean back as they drive. So there's a storage area at the front. You've got a robotic arm, and that can pick things up, store it here at the front, and the astronauts are at the back. Plenty of photos, that's the wheels. And let's see what else to say about it. They say here, there's two sets of computers, there's two batteries, there's two power distribution units, says Matthews. That way, a single micrometeorite strike or electronics malfunction in one component won't incapacitate the rover. It's really two rovers in one. So as you can see, it's extremely flexible. It can move around on a dime, as I say. They do a 180-degree rotation. That's awesome. So he wants Flex to be the picks and shovels of the new moon rush. We want to be the thing that enables anyone else who's got interesting ideas to make money on the moon. And then the third rover is Intuitive Machines, if I can start this video here. So it's the Moon Racer, the reusable autonomous crewed exploration rover, also known as the Moon Rover. You can see it's very wide. It's got joystick and no problem going over curbs. So it looks very fun to drive. Top speed is around 10 miles an hour. Again, you don't drive very fast in rovers, otherwise you're just going to slip, or you're going to topple over, or you're going to get stuck. Racer is the most enjoyable one to control. Each major system is hardened against errant micrometeorites and solar outbursts. No single impact can take out the vehicle. Their rover isn't as modular as Flex or as heavy duty as Eagle. It looks and drives like a dune buggy. It's the zippiest LTV of the three. Racer's design makes the towing capability more explicit, a key element rather than the bonus feature. So it comes with a trailer that you can tow stuff in the back. You can have an oxygen extraction unit on board. You could have a small nuclear power plant. So it can tow quite a lot. and who will win, the winner of which is expected to be announced by the end of this year. So NASA will just pick one of the three. All three companies have far exceeded NASA's minimum requirements for LTVs. For the public, the LTVs make the new lunar space race a lot more tangible. So that's really interesting. All three rovers look really cool, very, very useful, very functional, but NASA's only going to pick one. So I don't know whether the other companies that don't get selected will still continue with their rovers and potentially offer them to private companies. I guess we'll find out. Okay, so that's the stories I want to cover this week on the Midweek Space News Roundup. As always, here's the X account, Space Startup Hub. And yes, my next video will be on the situation with NASA and the new administrator. Hopefully Jared Isaacman gets approved. And I want to talk about his Project Artemis that has kind of been leaked. And he's also posted about it himself. So that will be my next video coming out in the next couple of days. So thank you for watching this, and I'll see you next time.